But much more importantly than all of that, I want to just introduce today's presenter, the last one of the day here in the innovation track. You're going to be hearing from Oden Technologies, a leading provider of AI-driven solutions for manufacturers. They specialize in transforming complex data into actionable insights for the frontline workplace. Now, you're in for a treat today because today's speaker is the co-founder and president of Oden. He's pioneering the use of AI and machine learning to enable real-time process optimization to improve factory performance. Please join me in welcoming Peter Brand to the stage.
That was, can you hear me? Is that good? That was a mouthful, thank you for that. And I am relieved to know that I'm no longer standing between a room of people and free margaritas. So this will be exciting regardless. And I mean, if there's one thing I've heard at pretty much every talk today, it's two things. You know, the importance of digital and AI and ML driven tools for operations, but you know, probably more than that, it's the acute challenges of the workforce right now and the importance of focusing on frontline workers, especially for planning on adopting something new like advanced digital tools and AI and ML. So I'll be covering both of those topics today, and especially getting into some real-world use cases about how to apply these new tools on the front line, best practices to get the right adoption, and to scale it ultimately in a sustainable way. Let's see if I get the clicker right here. There we go. So I'm Peter Brand, Chicago native, live in New York City where we're based. Oden's been around for 10 years now. We work with customers across industries, primarily building materials, specialty chemicals, inks, additives, packaging, paper, wire and cable, a few others. And really, you know, what we've been working on over the last 10 years has been the same mission. It's how to deliver the most powerful insights and actionable intelligence to operators and their support staff. You guys have probably been hit over the head with these stats all day, but I'm just going to revisit, make it black and white, not too painful. But manufacturing labor productivity has been flat or down since 2010. You probably heard the stat, you know, since 2019, average tenure has gone from 20 years to 3 years. To me, the most striking stat here is the 3-month retention rate, 90% in 2019, 50% today, probably worse. And I mean, talking to customers, talking to people today, some sites have 70% plus year-over-year turnover in hourly staff. So this is a problem. There's a lot of implications, but it's particularly acute because, I mean, most manufacturers, we're asking a lot of operators. There's variability up and down the production line. Different machines, different assets behave in completely different ways. You have changing environmental factors, huge SKU lists. I mean, we have customers with 1,000 SKUs, and each product behaves a little differently, runs a little differently, especially between lines. There's variance in length of runs. It's difficult to benchmark, you know, what's uptime, downtime, or ramp uptime, good uptime, to give operators a sense of where they should be. So all of this variation creates a huge bar for operators, and really it sets them up to fail. You don't have, you can't rely on a product running the same time every time, even on a given production line. And then you've got, you know, static recipes that don't accommodate for all of this variation. So the result really is that operators don't stick around long enough to become experienced operators. The training time, the ramp-up time, is years long, and they're out the door and they're in a new role before they can actually become somewhat productive, that 70% and above productivity. Ultimately, we need to bridge that productivity gap. So, I mean, what we've kind of roughly seen here is that new operators often operate well below the average or sort of the baseline, that sort of 25th percentile. Experienced operators operate better, you know, they're in that 75th percentile, but they're certainly not running things as efficiently or as well as they can, because they don't have the tools. They don't want to create issues. So where we want to get everybody is new operators operating like experienced operators, and experienced operators actually pushing the boundaries of what's possible on the line and reaching a more perfect state of production. Now, what's required to do that is, a data solution, AI, ML tools that account for this inherent variability in this new workforce reality instead of fighting against it, where you have dynamic recommendations instead of just static recipes to give the operators. And that's where Oden comes in. So you'll hear me probably say this a few times today, garbage in, garbage out, right? The baseline data is the most important thing. So we start with a data engine where you can kind of think of it as data ops as a service. We're gathering every data point on a production line that matters to the process. So that's real-time tags coming from sensors and machines in the automation system. That's also like offline data. That's maybe offline quality tests in a QMS system, or probably more likely some Excel spreadsheets. Offline product attributes in an SAP or ERP instance, MES. So we take all of those disparate data silos. We store all of that data. I mean, for some customers, we've got 1 trillion data points and above. But more importantly, we're cleaning that data, we're mapping it and contextualizing it all together in the way that it should to represent that run and that product. And we're inferencing and enriching that data so it's ready for building AI models and iterating those quickly, as well as any sort of other analytics you want to be doing. So we have what we call factory analytics. That's your more typical reporting, like dashboards, Pareto analysis, query tools for root cause analysis, alerting. That's the insights for what I'll call the operator support system. The supervisors, the process engineers, plant management. But then process AI is the ML and AI powered recommendations for operators in real time. I'm going to get into what that looks like in reality here. 2 other things that are in pre-release with a few customers right now. Knowledge AI is essentially taking the recommendations that we give in process AI, the what is supposed to be done to optimize on the line, and applying the how to do it by pairing it with LLMs that ingest work instructions, SOPs, machine manuals, OSHA requirements, whatever you want, in order to show the operator the work instructions for how to execute something, whether it's there on a set point or whether it's something around the line. And then Data Connect is how we actually export all of that enriched, cleansed data for whatever it is that a customer wants to do with that. People want to build their own old data science models. They want to ingest this data for other reporting, like financial reporting and projections in their ERP systems. We want to make that as easy as possible because we know that we're going to be probably one of a number of applications or use cases that AI and ML has to take part in. So this is actually what Process AI looks like on a tablet, on a computer, for an operator. And in this case, this is a paper manufacturing application. So if you're looking on the right-hand side there, those white tiles, the first thing that we're doing is actually predicting quality in real time. So a paper manufacturer, I don't know who here has been to a paper mill, but there's a lot of destructive offline quality tests that really matter. So here you've got tensile strength, moisture content, Z-ply strength. And what we're doing is we're taking those offline periodic tests that happen hours after the fact, and we're modeling it with all the process conditions that occurred when that piece of product was originally made. So the operator, the first thing they get is a second-by-second prediction of what those quality tests are so that they can then go do what they want to do to optimize with confidence. So then in the color panels there are the sort of, the select controllable variables that we've deemed most important with the customer to give the operator a very straightforward experience for, recommendations to take. So here you have line speed, material flow, steam flow, and we're telling them, the current setting and the recommended set point. Those settings are sort of generated, and if you see that in that, that scatter plot on the left-hand side there, we've got cost and line speed plotted there. This customer wanted to optimize for material and energy costs while keeping throughput the same or hopefully improving that as well. So we've got a scatter plot of 15-minute segments that our system has automatically pulled out of that product's history, where the process was stable and quality was good. So we're actually kind of picking along the efficient frontier there for what to replicate in terms of what the best combination is of cost and throughput. And what's fun on the bottom there for the operator in particular is we're giving them projected savings if they are taking these recommendations. So we're gamifying this in a way and giving them a real-time feedback loop of the impact they can make. So hopefully this is sort of showing you that there's also a bias towards simplicity here. Keeping everything really straightforward for the operator is key. They have a dozen things that they need to be doing all at once at any given moment, and we don't want to get in the way of that. But having a really flexible, sort of wide range of tools in your data science and ML toolbox is important to make sure that you're accommodating for different conditions, different applications, processes, things you want to optimize for. So the way I kind of see it is you've got real-time insights, real-time recommendations, what's happening right now, what should you do about it? On the what's happening now, you've got inline quality, and that's straightforward. We're going to be showing alerts to the operator about any inline quality tests that are happening in real time. Predictive quality, like I just mentioned, where we're actually building models to predict an offline test that isn't being measured in real time. And then abnormal conditions as well, where we can be telling them, look, something is off between your process variables here based off of the way that this product has typically behaved in the past when you're creating good product or when you're creating good quality. And then ranking that by impact and by cause so that if not the operator, a process engineer or somebody in that support staff can do something about it quickly. And then when we're delivering the recommendations, it kind of depends on what that application is or what you're optimizing for. Even the process, a paper manufacturer that has a sort of more complex process in some ways than maybe in a plastic extrusion line might be looking for different things, but you can use any combination of these where you have stable period based. That's where I mentioned where you're taking historical stable periods to replicate. You can also apply rules-based logic where it's essentially applying your own explicit domain knowledge to complement the algorithm and what's being recommended. I mean, a good example of this is we have customers where they have certain polymers, certain materials that they're processing that are more finicky, more sensitive than others. And they want to say, hey, look, we want the algorithm to recommend improvements, but let's only improve 5% at a time. Let's do the speed improvement of 5%. Let's then let the algorithm see that the process is stable for 5 or 10 minutes before we let it make another 5% recommendation. It's a way to marry the sort of more anecdotal expertise of a process engineer with the sort of observable recommendations of a model. And then you have simulation-based recommendations as well, where we're using AI modeling to predict and recommend outcomes based off of different sort of simulations of inputs. What's also important too is, we're talking a lot about how to use AI and ML for the end sort of application, the recommendations, but it's also important to use that to clean and process data for those end applications to begin with. One of the biggest challenges we've seen over the last 10 years is how to categorize time series data, time intervals of production. The sort of obvious case here is, MES systems, traditional SCADA systems, control systems, could do a basic logic of what's up and what's down. Hey, the motor's running or above a certain speed and, the line speed is above 0, it's uptime. That's not accurate enough, that's not high fidelity enough in order to give a model the right data set to pull from. That's dirty data. So we actually use models to infer and then label different segments of time, where in this case, there's actually a batch change start, there's a batch change sort of end with external activities, there's a ramp up period, and those different periods of time deserve more sort of specific and discrete time periods. That also puts a lot of time back into the pocket of the process engineers and the folks that would probably be doing this manually, if at all. So let's talk about the fun stuff. You know, what's the result of all of this? And I'll go through a real case here from the last 6 months in a wire and cable customer. We deployed Process AI to begin with at 2 of their extrusion lines, jacketing lines. And they wanted to focus on improving throughput while keeping quality and the overall process stable. On those 2 extrusion lines, they had 20 operators, you know, among the shifts that were going to be taking part in this. And in short, the results were 20% improvement in average production rate, over 5 million of added feet over historical benchmarks after that 90-day period. What was cool to see was that our system actually went back through their historical data for these products and took a look at the inherent speed variation first. So if you see that middle light green line, we noticed that the 75th percentile of speed on these products was roughly 12% faster than the average. So we agreed with them and said, let's set ourselves a ambitious goal, one that's going to produce a lot of value, but that should be achievable. And so we said, let's get halfway there to that P75. So a 6% improvement in performance. And you see here, quickly outstrip that basically on a daily basis. What's even more impactful or more important to me, if you bring it back to the operator and the importance of people, we outperformed historical production on 84 of those 90 days. It wasn't a couple big hits with some dips in between. It was consistent improvement across all 20 operators. Everyone participated. So we sort of reached that holy grail that we were talking about before, where you've got new operators behaving like experienced operators because they're getting very clear recommendations for what to do and how to accommodate that variation, that changing picture of what's happening on the line. And then you've got experienced operators actually pushing things to the limit, you know, running things where the spec should be and then going beyond that based off of their learned experience. So we're talking about the tech so far, and obviously that's important. But what we're talking about when you're handing operators, especially, you know, junior operators, AI and ML insights, this is a new way of operating for any manufacturer. And a new way of operating, a new mode of operation requires change. Change is hard, and that's something that demands a whole organization moving in lockstep with each other and being on the same page. So there's some rules that we've kind of learned over the years here that we try our best to follow, and I'll go into some specifics after this. But, you know, first of all, the operator is the customer. The operator has to understand what we're giving them, the importance of why, and it has to be catered to them being able to use it easily. But plant management, I'll call it, is the backbone. Supervisors, the shift managers, process engineers, plant manager, the whole support system that's ultimately there to make sure operators can do their jobs well. They have to understand the system. They have to be monitoring and pushing it on a daily basis and being there to support the operators when they have questions and feedback. I've heard this before, communication is key. We see it as shortening the distance between operators, the plant management, and then corporate leadership. Corporate goals and incentives and what they want to optimize for has to align with what's happening out there on the line in day to day. So constant transparency on expectations, on feedback, the required support that the local team needs in order to make recommendations work and to train everybody. And then, as I said before, simplify the action. I think Dan, the prior speaker, said if you put 5 engineers in a room, you'll get 1,000 things to do. That's certainly true. You got to narrow the focus to one goal to start. Is it throughput? Is it material cost and consumption? sustain adoption and success there, see that line go up and to the right for a few months, maybe apply it to more assets and sites, and then introduce more use cases, more things to optimize, only after you've established that beachhead and gotten some good momentum. Again, about keeping things simple for the operator. I was actually joking with Rebecca from room 1. I mean, room 4 is the best room, but joking with her that it's nice to think about optimizing things, but really where the rubber meets the road is just daily execution. It's doing the little things consistently over and over again so that you can then build upon that. So the little things to us make the difference. Here are some examples of what we do tangibly to drive this organizational change. My favorite, execs leading in-person kickoffs at every plant. The CIO, the VP of manufacturing, continuous improvement, folks and leaders from other sites who've maybe already done rollouts like this successfully. Get them standing in front of that site's personnel and tell them why this is important, their vision of their digital journey, their hopes and dreams for the company, and show them that they're there to work on this together. It's going to be imperfect, but it's about building momentum and supporting the front line. That goes a long way. Then supervisors leading daily huddles to review progress and iterate. And this is a big one too, because tangibly, operators are going to take recommendations. They're not going to take recommendations. It's really, really important to figure out, especially in those first few weeks, why they're not taking those recommendations. Is it because there was an external factor, like the material didn't show up to the line, or there was a power outage? Is it that the recommendation actually doesn't make sense? There's something that maybe Oden, the customer, needs to update in the models. Maybe there's some data that's just missing, and we need to fill that. Maybe it's a good training and learning experience that we need to fill in with the supervisors and the operators. Speeding up that iteration loop is what gets you to sustained success. It's not just sort of a magical, one-day overnight switch. This is change. Change is hard. This might be cheesy, but it's been a hit. T-shirts, hats, things like that to indicate that this is something everyone's doing to keep it visible. When somebody becomes a subject matter expert on Process AI or the Oden system, we give them a Process AI champion that's co-branded between the two companies. And people know that there's somebody that they can go to for help or for knowledge about this. Exec steercos to review ROI, to unblock progress. There might be something that corporate needs to do to maybe on the automation side, the IT side, to support the project. But again, to celebrate staff, we like to put pictures of people using it and enjoying it and anecdotes of what they like and what they don't like, so leadership understands the challenges and the success. And then at the end of the day, I don't think any of us want a new solution to sort of be like a standalone silo somewhere. This has got to support the existing SOPs and procedures and best practices that you have in your company. It's got to be in your lifeblood. So integrating with training and change management teams, continuous improvement teams, center of excellence, what they're focused on, what they need needs to be in lockstep with any sort of rollout of AR ML to the front line. I'll leave you with this, the new reality. The new norm is a 6-month workforce. It's people who haven't even been there a year. Growth requires operator-centric AI and organizational support for those people and to make that successful. One last little anecdote. We rolled out Process AI at another customer a few weeks back, 2 sort of problem lines historically. And within a few days, we improved throughput by 50, 60%. And we're standing there high-fiving, patting each other on the back, and the value stream manager comes up sort of deadpan and says, "Yeah, that's where we were running it 10 years ago." And I was like, "What? How could that be? That's 50%." And he says, well, we used to know how to do it. And he sees this solution as a way to take all of the disparate expertise and knowledge tucked away across the whole organization and put it in one place that's systematic, but that's at the fingertips of anybody who is actually running machines and lines out there. So ultimately, that's our philosophy on enabling the frontline workforce. Any questions? I've got 3 minutes and 40 seconds.
Thank you. Who had a question over here?
Thank you. Abbas here, Carlisle Construction Materials. So, 2 questions, if we have time. The first one being, do you see this more as for someone at the shop floor, like the operators running the line, or for the process engineer? Because the way we have been seeing it is the process engineers take the recommendations, they modify the recipes, and then they put in trials to run it, as opposed to the operators themselves changing it on the fly. So that's question number 1. Question number 2 is, I forgot, so we'll just go to question
Good,
number 1.
I'll take it one at a time. I would have forgot that too. Great question. I think it depends on the industry, on the process. I mean, some industries have more normal, like minute-by-minute variation where it's more operator dependent. Some industries, you have bigger assets, a lot of engineers looking at that asset and monitoring it all the time. I think the short answer is both. You need to have the process engineer, the supervisors, those subject matter experts kind of endorse and sign off on the logic and the approach that the models are taking. And that's why having visibility or transparency behind what's baked into the models is important, and we do that. But it also needs to be actionable by the operator in real time. If that industry allows, and there doesn't have to be re-regulation or recertification every time. Because if you're going back through that whole sort of investigative and approval loop, that's just another bottleneck to getting improvements out there on the floor. If the operators are making those improvements in real time, that'll go into the data history. The algorithms are going to be baking in those improvements as well and pushing the performance and the efficiency even further.
All right, well, let's give Peter a big round of applause. Thank you very much.
Thank you.